Hello everyone, this is Mr. Osama. Today inshallah we're going to talk about something very unique and important, which is areas of circles and sectors. Geometry for grade 9, chapter 10, lesson 7. This is very unique lessons. Before we start, we need to talk about the definitions of the circles, and we need to go through some new vocab. It will help us for understanding this session. So our session is focusing on the area of the circle and the area of the sector. So first of all, we need to understand what is the definition of the circle. So we need to go up a little bit. I'm gonna go up a little bit. I'm gonna draw a circle here. So the circle can be defined as a set of infinite points that has a constant distance from a constant point. We need to understand this is carefully. So I'm gonna change the color here. So I'm gonna have a point at here. I'm gonna have a point by the red color. It's gonna be at the middle here. I'm gonna name this point by C, and I'm gonna have another distance from the point to all. This is black curve. So we need to go back to the definition of the circle. According to what I said now, it's a set of infinite points. This is infinite points, has a constant distance from a constant point. We need to understand what does it means. So here I'm gonna start off with the definition of the circle. So circle, the circle is a set of infinite points, a set of infinite points has a constant distance from a constant point. So where is the constant distance and where is the constant points? Here, what are the constant, or what are the set of points here? So I'm gonna name all the points belongs to the black curve here. Start from here. This is point A, this is point B, this is point C. I'm sorry, not C, we need to find another B, B, C. This is D, this is E, this is F, G, H, I, J. All the points which I highlighted by A, B, D, E, F, G, H, I, J, and this is all the set of infinite points on the black curve. And the constant point which I meant here is the point C at the middle here. So all the red segments stands for the constant distance, and all the blue points, it's called the set of infinite points, and the C at the middle, it's called the constant point. So the definition of the circle, it's obvious and clear that a set of infinite points, which stands for A, B, C, A, B, D, E, F, G, H, I, has a constant distance which is C, A, or C, B, or C, D, or C, E, until you reach to C, J. This is what we call the constant distance from the constant point, which is the C. In this case, the constant distance has a specific name and the constant point has a specific name. So I'm gonna illustrate here. The constant distance, stands for the radius of the circle, which is R. The constant distance stands for the radius of the circle, which is r. And the constant point of the circle stands for the center of the circle. The center of the circle, which is C. So right now we got a new vocabulary, which is the center of the circle is gonna be the constant point, and the radius is gonna be the constant distance from the set of infinite points to the constant point, which is the center of the circle. So right now we can draw the circle by the new figure, which is this is the circle. I'm gonna draw a circle here with some notification. We are here. So I got this circle in front of your eyes now, that it has a center at point, we name it by C. This is point C, and it has a radius, which is the constant distance is 2.4 here. So the radius R from C to A point. So CA segment is the radius of the circle, and this is what we call the radius, because it's constant distance, and R of this circle equals 2.4 centimeters or in units. And the point C is called the center of the circle, the center of the circle. And this will cover the definition of the circle. Now we need to have the area of the circle. We need to study the area of the circle. First of all, we need to understand what is the meaning of the area. So the area means the area of the circle. The area of the circle is how many square units within the circle, within the circle. How many square units within the circle? So we had previous that we got the area of the circle in the other sessions, but we need to focus on it. So A stands for the area of the circle equals pi r square. Pi r square, and this is the mathematical formula of the area of the circle, and it measured by squared unit. Where A stands for the area, A stands for area, and pi stands for the ratio, which is 22/7 or 3.14. This is the value of the pi. And R stands for the radius of the circle. R stands for the radius. R stands for the radius of the circle. And the area of the circle can be measured by squared unit, as I said before. To understand this, we need to have a very easy example to make sure that we got the meaning of the area. So I'm gonna go up a little bit to have an example. Example number 1. Find out the area of a circle C with radius 5 centimeters. Find out the area of the circle C with radius equals 5 centimeters. So I have to write down the mathematical formula first, as I said before. So A stands for the area equals pi r square. So I have to use or to plug into the mathematical formula by the given information. But sometimes he didn't give you the value of pi, so it's up to you. You're gonna use pi equals 22/7 or 3.14. It's up to you. It's not here. You have no choice. No, you have a choice. You do have a choice, so it's up to you to use whatever you need to use. So I'm gonna use 3.14 as usual, so I'm going to say 3.14 multiplied by the radius, which is 5 powered by 2. Then I'm going to use my calculator to find out the area of the circle. So I'm going to multiply by using my calculator 3.14 times 25. The final result of the area is going to be 78.5 centimeters square, which is the area of the given circle. On the other hand, sometimes the question asks you to find out the area in terms of pi. If the question asks you to find out the area in terms of pi, that means you're not allowed to use the value of pi, which is 22/7 or 3.14. So we need to have another example for that. Example number 2. Find out the area of the circle C in terms of pi. What does it mean? It means I'm not gonna substitute by the value of pi, so I'm gonna leave it as it is. With radius r equals 7 centimeters. So right now, to solve this example, we need to write down the mathematical formula, which is area equals pi r square. Somebody will say I'm gonna replace pi by 22/7 or 3.14. This is not right in this case. Why? Because the question asks you to find out the area in terms of pi, so I have to leave pi as I'm gonna say equals, keep pi as it is, multiplied by 7 powered by 2, which is 49 pi square centimeters unit square. So 49 pi centimeters square, this would be the final result of the area with respect to pi, or including pi, or in terms of pi. And this will cover the first part, which is find out the area of the circle by using the mathematical formula A equals pi r square. By the end of this example, we covered theorem 1011, which is the area of a circle is the product of pi and the square of the radius. So will cover theorem 1011, which states that the area of the circle is the product of pi and the square of the radius, which is A equals pi r square. We need to move to the next part of the our lesson, which is the sector. What is the definition of the sector? To understand the meaning of the sector, so number 2, the second part of our lesson is number 2, which is the sector. We need to understand what is the meaning of the sector. To have a look about the sector, we need to go through some graphs. So I'm gonna graph a sector here, and this will be the sector. It's a part of the circle, but it has some condition. What is the condition of the sector? The sector, as you look here, it is bounded by 2 radii and a part of the circle, which is called the arc. So this is radius, so I'm gonna change the color. This is radius. This is one radius. This is one radius. I need to change it. This is one radius. And this is another radius. And this is what we call the arc. So here, this is part of the circle, which is I highlighted now by the red color, bounded by 2 radii and 1 arc by the end points of the arc. So the arc has 2 endpoints. I'm gonna name this point here by A, for example, and this is endpoint by B, and the center of the circle, which is O, for example. So here we can identify the arc, which is a region bounded by an arc of the circle and the two radii to the arc's endpoints. Again, what is the definition of the sector? A sector is a part of the circle bounded by an arc of the circle and the two radii to the arc's endpoint. Two radii, which is RR, by the end of the arc's endpoints, which is A and B, and this is area. This is area which is called the sector of the circle. The sector of the circle. So right now we can write down the definition of the sector. That sector can be defined as sector. It is a part of the circle. It's a part of the circle bounded by two radii and one arc and arc, two radii and an arc and arc from the endpoints of the arc, from the endpoints of the arc, from the endpoints of the arc. This will cover the definition of the arc according to our student book. So right now we need to study how to get the area of this arc. As I said now that the arc is a part of a circle, so arc has a ratio from including to the circle. So right now we can say that part, according to the word which we had, that the arc is a part of a circle, so we can find out the ratio of the arc and comparing with the circle which it comes out from. So right now we can find out the ratio of the arc to get the area of the arc. How to get the area of the sector? Area of the sector depending on the ratio of the sector. The ratio of the sector. What if the sector represents from the whole circle? So to understand the way to get the area of the sector, we need to study something very important, which is called how to get the ratio of the sector. How to get the ratio of the sector. So I'm gonna write down here how to get the ratio of the sector. How to get the ratio of the sector. We need to study this by two different ways. So I can get the ratio of the sector in two different ways. If the ratio, I'm gonna use two parts here, so I'm gonna divide the screen into two parts. To get the ratio by using the length, and to get the ratio of the arc by using the measure of the central angles. I'm gonna use here method number 1 and method number 2. How to get the ratio of the sector? By the first part, by length, by the length, and here by the central angle. So I have two different ways to get the ratio of the sector. If the question gave you the length of the arc, so I have to go through some specific formula. If the question gave you the measure of the central angle, you have to use a different way to get the ratio of the arc or the ratio of the sector. How can we do this? If the question gave you the length of the arc, so length of the arc, the length of the arc given, then I'm gonna use the mathematical formula, the ratio of the arc equals the length of the arc over the circumference of the circle, which is 2 by r. So here I'm gonna say length of arc over 2 by r, which is the circumference of the circle, 2 by r. So I'm gonna focus again. If the question mentioned the length of the arc, to get the ratio of the sector, you have to divide the length of the arc by the circumference of the circle. If the question gave you the measure of the central angle, you have to say ratio in the second part, ratio equals measure of the central angle. Sorry, I'm gonna make it a little bit. Measure of central angle, central over 360 degrees. So I have two different formulas now to find out the ratio of the sector. The first one, I have to focus on the given information. If the given information states that the given is the length of the arc, you have to divide the length of the arc over the circumference of the circle, which is 2 by r, to get the ratio of the sector. To get the ratio of the sector by using the measure of the central angle, you have to divide the measure of the central angle over 360 to get the ratio of the arc. Somebody will ask me, what will happen if I got the ratio? Then you have to multiply the ratio of the arc or the ratio of the sector by the area of the circle to get the area of the sector which is required. So once you get the ratio, it's easy now. So we need to move to the next step, which is once you got the ratio of the arc or the ratio of the sector, the same meaning, then area of sector equals ratio multiplied by area of the circle, area of circle, and this will complete the area of the sector. So right now we're done with the mathematical formula to find out the area of the sector. First of all, you have to get the ratio of the sector, then you multiply the area of the ratio of the sector by the area of the circle. It will give me the final result, which is the area of the sector. We need to have an exercises to cover what we've been through now. So I'm gonna get a circle. I'm gonna draw a circle here. This is a circle with center. I'm gonna identify everything now. So here, this is circle. This is circle with center C and radius 3.6. This is circle. We need to identify the sector. So I'm gonna graph a sector with a specific This is the first part. So I'm gonna identify a sector here. This is sector. It has endpoints. I'm gonna illustrate the endpoints. This is measured. The central angle will be, for example, 85 degrees. 85 degrees. The measure of the central angle, which is 85. So I'm gonna say this is C, this is A, and this is B. So here, find out. The question will be example number 1. find out the area of the sector whose central angle is 85 degrees and the radius is 3.6 centimeters. How can I find out this? I have to focus on the given information. The given information here gives me the central angle measure, so I have to go back to the second way for finding out the ratio of the sector. So first of all, I need to find out the ratio of the sector. I need to find out the ratio. So ratio of the sector equals 85 over 360. It will be my ratio. So I'm gonna divide it 85 over 360. The final result will be 17 over 72, and this will be the ratio of the sector. Once you get the ratio of the sector, you have to multiply this ratio by the area of the given circle. It will give you the area of the sector which is required. So I'm gonna go up a little bit. I'm gonna say here area of sector equals ratio multiplied by area of the circle. So it's gonna be, I got the ratio 17 over 72 multiplied by the area of the circle, which is pi r square. I'm gonna plug into this is given information, so it's gonna be 17 over 72 multiplied by which is 3.14 or 22 over 7, is up to you, multiplied by r, which is 3.6 powered by 2. 3.6 powered by 2. I think this is the correct answer. Yes, 3.6. So I'm gonna get back to the calculation here. I'm gonna use my calculator to find out the final result. 3.14 multiplied by 3.6 final result will be 9. The area of the arc will be equals 9, after this calculation, it will be 9.6084 centimeter square, and this will cover the answer of the questions. Right now I used the mathematical formula for getting the value of the ratio or the ratio of the sector by using the central angle measure. We need to have another example to use the other method for finding out the ratio of the sector by using the length of the arc. So I'm gonna move up to find another question. Exercise number 2. I'm gonna draw a circle. I'm gonna do a circle here. This circle has a specific information, so I'm gonna highlight it. So it has 4.6 as a radius. Then I'm gonna highlight the sector by different color. I'm gonna pick up a sector from this circle. This is sector which highlighted by the 2 radii, red radii and 1 blue arc. We need to find out the area of the target sector here. So the question is find out the area of the sector which has been highlighted like this. The area of the highlighted sector whose length length is for example 15 centimeters, for example 15 centimeters. How to find out the area of that sector? As we said before, that we need to find out the ratio. So the solution will be, I'm gonna move up a little bit, solution will be the ratio of the sector, ratio equals length of the arc, length of arc over the 2 by r square, 2 by r only, I'm sorry, 2 by r. So I'm gonna focus on thing the 15 centimeters, which I said before, whose length is the length 15 centimeter for the arc, for whose arc is 15 for the arc, not for the sector, for the arc. And I have to focus on this is arc will be here, the red one. This is arc, which I highlighted now. It has 15 centimeters length, 15 centimeters. So I'm gonna get back to the mathematical formula to find out the ratio. So I'm gonna say ratio will be, the ratio will be 15, which is the length of the arc, divided by 2 multiplied by 3.14 multiplied by the r, which is 4.6, and this will give me the ratio of the r. So I'm gonna calculate this by using my calculator. So I'm gonna divide it, 15 divided by 2 multiplied by 3.14 multiplied by 4.6. The final result will be, the ratio will be the ratio in a decimal form, ratio of the arc, or the ratio of the sector will be 0.519, and this will be the ratio of the sector. To find out the area, so I'm gonna say area of sector, it will be the ratio multiplied by the pi r square, which is the area of the given circle. So I'm gonna say the ratio equals, the area equals, I'm sorry, 0.519, this is the ratio, multiplied by the pi, which is 3.14, multiplied by r square, which is 4.6 powered by 2. By using my calculator, I'm gonna find out the value. So 0.519 multiplied by 3.14 multiplied by 4.6 power 2. The final result will be 34.48 centimeter square, and this will cover the area of the sector which has been illustrated. I need to give you some remark or axiom here, that circles, when you highlight a sector, you have two types of sectors. So I'm gonna illustrate this by remark. So remark here, remark number 1. If this is a circle with a center O, I gonna highlight two sectors, one black here, the black sector. This is black sector, is the minor sector, and this is the large sector. This is the large sector, and this is the small sector. This is the small sector. This is the small sector. So the highlighted black sector is a small sector, and the red one will be, the large, the red one will be the large sector here. So I have to highlight this to make it easy for you. So once you got the sector, you have to know which one is required. But in general, if the question asks you to find out the area of the sector, the question asks you to find out the small sector area, not the large. He always asks it for the small sector, not the large sector, and this is very important. So remark the large sector. If the question asks you to find out the area of the largest sector, that means he will mention it. But if it's not, he will give you find out the area of the sector. It means the small sector, not the minor sector, not the large sector, not the large sector. Once we're done with the sector, we need to move to another vocab or another topic, which is called the segment of the circle. Segment of the circle. What is the definition of the segment of the circle? So number 3, the part number 3 of our session is the segment. The segment of the circle. Assume that we have a circle with a center O or C, and I have a chord. A chord is called AB chord, and I'm gonna highlight the area here. The blue area here, this is blue area, stands for what we call the segment of the circle. This is blue area, stands for the segment. This is the segment which we need to identify. So the segment of the circle, it's a part of the circle bounded by a chord and the arc by the end of this is chord, by the ends of, or by the end points of this is chord. So again, the segment is a part of a circle bounded by an arc and the chord by the end points of this is chord. So we need to write down the definition of the segment. I'm gonna identify the segment here. So segment, it is a part of a circle, is a part of a circle bounded by a chord, and an arc with the end points of the chord, with the end points of the chord. The next thing we need to identify how to get the area of this segment. This is another challenge, we need to do it. How to get the area, how to get the area of the segment. This is our challenge. It's very easy. Once we draw it, it's gonna be easy for you. So I'm gonna draw here a circle. I'm gonna draw a circle with center O, for example, with center O here. This is C, which is the center of the circle. I'm gonna do the sector which bounded by AB arc, and I'm gonna line up the AP, which is chord. So the red area stands for the segment. The red area stands for the segment. I need to find out the area of the segment bounded by the chord AB and the arc AB. So first of all, you guys can find out the area of the sector bounded by the two radii and the arc AB. You then subtract the area of the triangle, so I'm gonna make it green. The area of the green area, which is the area of the triangle. I have to find out the area of the triangle and then subtract the area of the triangle from the area of the sector. It will give me the area of the segment. So I can see here the area of segment equals area of sector minus area of triangle, which is green. So the area of the sector minus the green area, it will give me the red area, which is target, the area of the segment bounded by the chord AB and the arc AB at the same time from its end points. I think you guys got to understand what we've been through now. So I hope you understand all the formulas which we had, and I hope you understand what we've been through. Thank you for watching the video. Inshallah, I'm gonna meet you again in another video with some exercise to cover all the areas which we've been through. Thank you for watching the video. Have a good day. Goodbye.